Hey everyone, welcome back. On behalf of Forge College, I am absolutely thrilled to be your flight director today. We're continuing our journey through the capstone, building a complex Solana program module. Now, in our previous lesson, we were busy designing integration tests, right? Making sure our code does exactly what it's supposed to do in a nice, safe, controlled environment. Well, today things get real. We're going to treat this explainer like a high-stakes rocket launch. We're transitioning away from those cozy local tests and moving straight into a professional, operations-heavy deployment phase. Basically, we need to make sure our payload actually survives the journey to mainnet.
Okay, let's take a quick look at today's flight plan. We'll start with a welcome to pre-flight, gather your deployment artifacts, build out an automagic deploy script, run a staging dress rehearsal, get our verification and sign-off, and finally, get ready for mainnet.
Let's dive right into Section 1. Welcome to pre-flight.
So we're kicking off our pre-flight sequence by checking out the payload we built previously. These deliverables, well, they form our baseline. We're talking about your test artifacts, a passing test matrix and staging, a list of any unresolved integration issues, and your deployment checklist scaffold. But you know, writing brilliant code is really only half the battle. Think about it. A mathematically perfect program that deploys with a completely wrong upgrade authority, yeah, that's just a very, very expensive mistake. We need a foolproof process.
Moving right along to Section 2, your deployment artifacts.
All right, now we move into the assembly phase. And this really comes down to the stark difference between an amateur's sweaty, error-prone manual deploy at 2 in the morning and a professional's reproducible, totally stress-free scripted deploy. I mean, if you're out there typing commands into your terminal one by one, just crossing your fingers and hoping your environment variables are right, you are literally playing Russian roulette with mainnet. So we're going to take that guesswork out entirely.
To get this right, there are exactly 4 essential components you must assemble in your repository to guarantee a deterministic outcome. Think of them as your launch essentials. First, you've got your compiled binary, that .so file, which has to perfectly match the program ID in your integration tests. Second is your automated deploy script. Third, your machine-readable deploy checklist YAML file, which we're going to use for CI gating and human sign-off. And lastly, your integration report JSON outputs. If you have these 4 pieces neatly organized together, you've got exactly what it takes to launch safely.
Up next, Section 3, the automagic deploy script.
Let's lift the hood and look at the engine powering this launch, your automated deploy script. Before you even think about firing the engines, you, as the flight director, must run through some absolutely critical environment checks. Because honestly, the very last thing you want is to accidentally drain a mainnet wallet over a silly typo. So confirm your Solana CLI version matches your integration tests. Ensure your keypair points to a funded staging pair. Keep those mainnet variables strictly commented out and store all your logs safely under the dist directory.
Here's the sequence. The script sets your safe staging environment variables, builds the artifact, and deploys it to the cluster. But then, it does something incredibly smart. It automatically extracts the program ID and transaction signature directly from the output log. No manual copy-pasting required, no human error. From there, it checks the Solana account to confirm the program is actually present and immediately runs a lightweight post-deploy verification. It's like magic, but better because it's code.
Which brings us to Section 4, staging, the dress rehearsal.
Okay, it is time to fire the engines without actually leaving the launch pad. Once your script deploys the code to staging, we immediately run a smoke test. A smoke test is basically a minimal set of cross-program invocation tests run right after deployment to prove your core functions are actually stable. It's a vital operational check to ensure your expected account layouts and behaviors actually survive the launch. If something breaks here, you find the root cause and squash it way before mainnet.
Now check out this specific bash command, set-euo pipefail. We put this tiny string of characters right at the top of our deploy script, and it is an absolute game changer. Why? Because if a smoke test fails or a variable is unbound, the script exits instantly. It fails fast. This prevents those terrifying zombie deployments where half the script runs fine and the other half silently errors out in the background. It's a small command, but it acts as a massive safety net. All right, moving to Section 5, verification and sign-off. Our dress rehearsal is a wrap, but before we do this for real, we need Mission Control's official green light. We record every single deterministic output into a parsable YAML file. You log the step, the timestamp, the cluster, the generated program ID, the deploy log, and whether the smoke check actually passed.
And because this is completely machine-readable, your continuous integration pipeline can literally just parse the file to decide if it's safe to proceed.
But wait, notice that very last field in our checklist file, signed_by. Now you might be super tempted to just type your own name into that field to speed things up and get it out the door. But take a step back and ask yourself, why is that a completely terrible idea? Why shouldn't the person writing and deploying the code be the one signing off on it?
I'll tell you why. Because peer review prevents mainnet disasters. Never, ever trust your own tired eyes at the end of a long sprint. Someone else on your team has to step in, verify those logs, run the smoke tests independently, and provide a cryptographic signature or CI approval. That signed-by field stays strictly empty until your copilot verifies the work, no exceptions.
Finally, Section 6, ready for mainnet. We have done the hard work. We've automated, we've tested, and we've documented. And it really all boils down to two undeniable laws of physics for this module. Reproducibility beats manual steps, so script every action. And verification must be machine checkable. If it's not scripted and machine checkable, it simply is not ready for mainnet. Never rely on manual terminal commands for a production launch.
So, armed with your pristine staging run artifacts and your pure signed checklists, you are fully prepared for the final assembly of your complex Solana program. You've successfully closed the loop between your initial planning and your integration testing evidence. Your very next move for the capstone submission will be to pull all of this together, perform the full assembly, produce your final docs, and run those final gated checks.
I want to leave you with one final critical question before we wrap up this explainer. Look at your own project right now. Are your artifacts fully reproducible? And are your operational checklists definitively signed off by a peer? If you can confidently answer yes to both, then my friend, you are ready for launch. Thank you so much for joining me today. If you found this breakdown helpful and want to dive deeper into advanced Web3 engineering topics, head over to forge.college. We've got an absolute ton of incredible resources waiting for you there. Keep scripting, keep verifying, and I'll catch you in the next one.